So the next thing that we're going to have a look at is we're going to look at sketching for a domain, and then we'll spend a little bit more time looking at these key points of a graph and a couple other things. So we're going to look at sketching for a domain, and then key points of a graph. So let's use the same function as we did before, which is this thing here. So once again, we'll define it as being h of x, and then we'll go through a couple of things from there. So where's CAS? Here it is. Define h of x equals negative 2x squared plus 30x plus 48. Run that. Okay, so we define that. So that's done. So now, like we did before, we're going to graph this. So we'll go to Home, Graphs, and we'll say we're graphing h of x. Because we define it, we don't have to do anything else. This is a bit different. Anyhow, I must have typed it in wrong incorrectly. Doesn't matter. So let's go, and once again, menu and window trace. Let's set our graph, or sorry, set our window. So we're going to go from, say, -2. We're going to go to, say, 20. We're going to go from a minimum of -2 and then a maximum of, say, 52. So it gives us a nice view of the graph. Something's amiss. Why is this going higher than, oh no, that's where the intercept is, 48. We have to go a lot further out than this. Menu, window zoom settings. Let's zoom out to a Y maximum of, say, 80. Let's see if this works. No, still not right. Menu, window zoom, let's go out to 100. Still not right. This is where I want to say a bad word. How far up are we going? So we're going to 100, and so if I zoom out to 120, or 180 rather. Windows zoom settings, -1, 16, we'll go to say 20 still, Y minimum of -1, and a maximum of 180. There we go, now we see our graph. Okay, so once again, so that's why we do it. Now, if we want to sketch this, hang on, let's change this a little bit. Window settings, let's go to -15. So what we can see here, we can see that the graph goes from here to here. Now, because of the context of the problem, this part here isn't real and this part here isn't real, because it can't happen. The window starts here. We know that. We know that Miss Green's not throwing it from infinitely back down somewhere here. She's throwing it from here, and it's going here, and then it hits the ground here, and it's not going to continue on going. It's not some sort of magic water balloon that goes through the ground. So what we want to do, we want to define a domain. So to define a domain, what we do is let's say we just want to graph this from 0 to, I don't know, 15, for example. So we're going to graph it between 0 and 15. So what we do, we'll go back to this, and we'll redefine this by pressing up twice, except now rather than just pressing enter here, what we're going to do is we're going to go to control and this, and we're going to do that. That's given. We're going to say given that 0 is less than or equal to x, which is less than or equal to 15. So now it's graphing it. Now we've defined the function for this domain, 0 to 15. If we go back to our graph and we have a look at it, we can see that it stops here at 15. So that's how we go about sketching something over a domain. That is this thing here, sketching for a domain. Okay, and that's how we go through that. So just to have a look at that again, what we do, we define our function, h of x, whatever it may be, and then we put given, and then we state our domain, and we can change it to whatever we want. If we want to do this between, say, 15 and 16, make 15 and 17, we can now see that it's changed it, it's graphing it from there. We can set this to, whoops, sorry. We can go from 0 to 16 and have a look at it there. If we want to sketch it for an intercept, then we would solve h of x equals 0 for x. Let's tell me that because I've defined the domain. So I'll redefine it. Solve. And then we've got two values. I'm not going to put those in though. That's too confusing to play around with. But that's how we go about sketching over a domain, or how we define a function over a domain. So we define it, define like we normally would, then control this thing here, given between 0 and or whatever value, our minimum value is less than or equal to x, our maximum less than or equal to our maximum value of say 12, enter, it's done. We check out a graph and it goes from 0 to 12. Now once again we want to find out some so that's what we got there. So we'll sketch of a domain. We've looked at how to find key points in a graph. We found their x-intercepts, our turning points. So that's all that we've got to do there. The next thing we've got to have a look at is how we can look at new equations from transformation. So we'll do that next.